Good morning, Class 3 and Class 4. Welcome to your reading session for today. Okay, so today we're going to continue with Titus rules, okay? I'd like you to read chapters 4 and 5 today. If you'd like to pause me now while you read them and then come back when you're ready for the questions. So, you've got quite a few questions today, but a lot of them are quick fire recall questions, all right? So, can you name the 4 places the Queen stayed? Why did Queen Elizabeth allow Titus to visit the drawing room at an earlier age than the other puppies? Why did Prince Philip prefer terriers to corgis? When is the Queen at her happiest? What do you think the word scarcely means? Have a look on page 45, you might get some clues there. What are the Queen's 3 sons called, and which one is the Prince of Wales? And what is the Queen's favourite lunch? Pause me now, guys, while you have a go at those, and then come back when you're ready. Okay, your answers are there for you. So the Queen stayed at Buckingham Palace, Windsor Castle, Sandringham, and Balmoral in Scotland. So Titus was allowed to visit the drawing room at an earlier age because he was the only surviving puppy from Prissy's last litter. Prince Philip prefers terriers to corgis because they get out of the way, whereas corgis trip him over. And the Queen is at her happiest when she's with her dogs, especially with Titus. Scarcely means only just or a short amount of time. The Queen's 3 sons are Andrew, Edward and Charles, and the Prince of Wales is Charles. And then the Queen's favourite lunch is Marmite sandwiches and cold rice pudding with strawberry jam. Okay, hopefully you've all found those okay, and I look forward to continuing reading with you tomorrow. Hi Class 4, welcome to your maths for today. We're going to continue exploring equivalent fractions, so same as it's been all week. Don't pause the videos when he tells you to do the worksheets. Do the ones at the end, please.
Hello and welcome to our second lesson about equivalent fractions. Let's just remind ourselves of that word, equivalent, which we can see at the beginning of it has got the word equal, which we know equal is the maths word for the same. Okay, so we're going to be looking at fractions that have the same value as each other today. Let's take a fraction that we've come across before, and we're probably quite familiar with this idea now, of a fifth, 1 of 5 equal parts. And I've shown a fifth using a bar model there. Okay, so I've shown a fifth below. What I'm going to do is I'm going to split my bar model in half horizontally. I've now got 10 pieces, haven't I? If we count up, we've got 5 on the top, then we've got another row of 5, so we've got 10 pieces. How many are shaded? 2. We started with 1/5, and we slightly changed our bar model, so now we've got 2/10. Those two are equivalent fractions, 1/5 and 2/10. In yesterday's lesson, I talked about looking at the relationships between numerators and denominators. We're going to look at that in a lot more detail today. Can you see anything, though, about 1 and 2, 5 and 10? Just have a think about it. Here we've got a half. This time, I'm going to split my half vertically. Now I've created twelfths. How many twelfths are shaded? 6. So 1/2 and 6/12 are equivalent. They're the same. And we can really clearly see that on our bar model. If this was a rectangular shaped pizza and someone had half of it and someone had 6/12 of it, you can see really clearly that they've eaten just the same amount. So you have a go now at completing the equivalent fraction for 2/5 using that bar model. Okay, so hopefully you jotted down the bar models and you shaded just like we've done on the 2/5, but here we've shaded 4/10. How about this one? No shading whatsoever done there for you, so got to shade both bar models in. Okay, so 3/4 would be shaded like that. Of course, it could be any 3, but as long as it's 3 of the 4. So then, below, we've got 12ths here. We're going to shade those in. 9/12. How about this one? So we've got 1/4, and we can see we've got 8ths below, 2/8. Let's look at that equivalent fraction, 1/4 and 2/8, in a bit more detail. So what I've done there is I've given you 1/4 and 2/8, but then I've also shown lots of other equivalent fractions for 1/4. So all those 5 fractions have the same value as 1/4. What do you notice? Thinking particularly about the numerators and the denominators. Well, if we look at the first 2 equivalent fractions, 1/4 and 2/8, we can see we've multiplied the numerator by 2 and the denominator by 2. We've doubled the numerator and the denominator to get an equivalent fraction. Let's have a look at 1/4 to 3/12. This time we've multiplied top and bottom, numerator and denominator, by 3 to get an equivalent fraction. To 5/20, we multiplied by 5. And what about to 10/40? We've multiplied by 10, haven't we? And that's how we can create equivalent fractions. If you have a fraction and you multiply the numerator and the denominator by any number, as long as it's a whole number, you will get an equivalent fraction. So here, if we had this question, we need to make these 2 equivalent. So we've got 1/6 and something over 18. Let's think about what we've just learnt about this multiplying by the same for top and bottom. Well, we can see we've got both denominators here. What's the relationship between 6 and 18? What have you got to multiply 6 by to get 18? So it's think about our 6 times table knowledge. We've got to multiply it by 3, haven't we? 6 times 3 is equal to 18. So what do you think we're going to multiply the 1 by, the numerator? Go and multiply that by 3. 1 times 3 is 3. So 1/6 and 3/18 are equivalent. And we could, of course, draw it to show that, but we're now using our mathematical understanding of multiples to be able to find these equivalent fractions. So there's 1/6 and there's 3/18. So we can see they are equal to each other. And we can put that sign in to emphasize that. Let's think about these 2 questions. We've got 5/20 is equal to 1 something. So let's have a look at the numerators. Well, we've divided by 5, haven't we? We can have it both ways, dividing and multiplying with the numerators and the denominators. So 5 divided by 5 is equal to 1. That's what we've done to the numerator. So what are we going to do to the denominator? We're going to divide it by 5. 20 divided by 5 is equal to 4. So 5/20 is equal to 1/4. They are equivalent fractions. What about this bottom fraction? We've got a missing numerator. So we need to look at the denominators and let's think about what's happening. This time we're given the fraction on the right, so we've got to work to the left. What do we have to multiply 10 by to get 40? We've got to multiply it by 4, haven't we? 10 times 4 is equal to 40. So what do you think we're going to multiply the 3 by? The numerator by? 4. 12. So 12/40 is equal to 3/10. They're the same value. Do you think those 2 are equivalent? Well, what's happened to both of those numerators and denominators? We've added 2 to each. So some people might think, oh, I've done the same thing to numerator and denominator, so that's fine, I've got an equivalent fraction. But when we say we talk about the same thing, we talk about multiplication and division, aren't we? We've got to multiply by the same or divide by the same. And we can see that really clearly, that that is not an equivalent fraction. If we draw them, 1/6, 3/8, we can see 3/8 quite a bit bigger than 1/6. I'd rather have 3/8 of a chocolate bar than 1/6 of the chocolate bar. Using that knowledge now, have a go at completing those 2 questions. So number 1, we can see with our numerators 2 times 3 is 6. So for our denominator, 3 times 3 is 9. Number 2, we're given the fraction on the right hand side, so we've got to work right to left, and we're going to be dividing, aren't we, because we've got 25 and 5 in our denominators. So 25 divided by 5 is 5. So for our numerator, 20 divided by 5 is 4. So 4/5 is equivalent to 20/25. And let's have a go at the same idea with those 2 questions. So these 2 questions might look a bit more challenging because the numerators and the denominators are larger. We don't often see fractions with 77s in the denominator, for example, but it's just the same idea. Number 3, we've got to work right to left. So we're given 33 and 3 as our numerators. So we divide by 11 to get from 33 to 3. So we're going to divide by 11 from 77 to 7. 3/7 is equal to 33/77. And number 4, well, hopefully we're really comfortable with the relationship between 50 and 100. It's double, isn't it? So to get from 50 to 100, we times by 2, multiply by 2. So we're going to double, we're going to multiply by 2, 19, to get 38 hundredths. And what we're doing when we're multiplying by the same amount or dividing by the same amount, we're keeping the relative sizes, the comparative sizes, the proportions the same. So the difference between 19 and 50 is the same as between 38 and 100, that one is the same amount smaller or larger than the other in both fractions. So we've got a matching activity here. Match the fractions on the left with their equivalents on the right. So for me, I wouldn't actually start at 12/30. I'd start at 1/4 because that's the unit fraction. That's the fraction I'm most comfortable with. So I can see, and I've got 1 in my numerator, so it's really quite easy to see, to work down the different numerators and think, right, what can I multiply 1 by to get 5? So I could think, is it 5/8? Well, 1 times 5 is 5, fine, so I need to multiply the 4 by 5. 4 times 5 is 20, so no, because it's not, doesn't say 5/20. So it's not that first fraction on the right. So in fact, that one isn't it. We're going to multiply top and bottom, numerator and denominator, by 7. So 1/4 is equal to 7/28. And then we've got a divide by 6 there. 12/30 is equal to 2/5. And that leaves that one. 15/24 is equal to 5/8. Here we've got a problem. Let's have a quick read of that. When I first read that, I couldn't really work out where fractions were coming in, but we will see as we work through the problem together. Okay, so I think the first really key piece of information I can see here is that they've both got rope, and the ropes are the same lengths as each other. So let's show this situation in a bar model. They're the same lengths as each other. And we know Rosie cuts her rope into 3 equal pieces. So I'm thinking with Rosie's rope, we're dealing with thirds, 3 equal pieces. So we can possibly see now some fractions are involved here. So 3 of Mo's pieces are the same length as 1 of Rosie's pieces. How can we show that on our bar model? There's 1 of Rosie's pieces, and there's 3 of Mo's pieces, and we can see they're the same length, so they're equal to each other. How many pieces does Mo cut his rope into? Well, we know Rosie's cut hers into 3. How many has Mo cut his into? Well, for each 1 piece of Rosie's, there are 3 pieces of Mo's, aren't there? So he's got another 3, another 3. So he's cut his rope into 9 pieces. So we sort of saw a little bit of a hint of how our equivalent fractions understanding is important there. Let's break it down into more detail. There we've got our 2 bar models. We've got Rosie's thirds and Mo's, in fact, ninths. So we can see the equivalent fraction, can't we? 1/3 is equivalent to 3/9. If you have the White Rose Maths worksheet for this lesson, equivalent fraction.
Okay, the questions are there for you on the screen. These are the ones I'd like you to do today. Pause me while you do them and then come back when you're ready to go through the answers. Okay, your answers are there for you on the board. If you're looking and you're thinking, oh my goodness, I've not got these and I'm not sure why, please send me an email and we'll go through them together. Okay, so on to your writing for today.
Good morning, Class 3 and Class 4. We're on Wednesday the 8th of July, and for your writing today, we're going to be planning an advert that's going to be written by the Queen. Today, you are all the Queen. Okay, so pause now so you can get that written down. So firstly, what I want you to have a think about is what makes Titus the Queen's favourite? What is it she loves about him? And if she was to have another corgi, what would she want them to be like or be able to do? So if you think about an advert, if somebody wants to hire somebody, or if someone is looking for someone or for something, or a person in particular who has a certain set of skills, they might write an advert that goes perhaps in a newspaper or goes up in a shop window, looking for people to come and do a certain job. So think about what the Queen wants her corgis to be able to do. Think about what she loves about Titus so much and why she likes Titus, why Titus is great. Okay? Tomorrow we're going to be writing an advert from the Queen explaining what she's looking for in a corgi. But today we are just going to plan what to write. Okay, so we're not doing the final thing today, we are just planning it. Okay, so your task today then is you're going to plan what you're going to include in your advert. So think about what qualities and skills are you looking for in a corgi. Remember, you're the Queen. What do you want them to do? And what will they need to do if they come and live with you in Windsor Castle? So in your book, write a list of what you want to include in your advert, what you are going to be looking for in your corgis, because remember, you are the Queen. So it's just your plan today, so just write a list of those things that you know you need to include in your advert. Okay guys, and I will see you tomorrow where I will show you some examples of adverts ready for you to write your own.